All right, here we go. Have a look. So there's the answer. How come? Let's have a look at this. So if we were to just combine like terms here, right? This is the stuff we're working on now with polynomials, just adding and subtracting polynomials. So this first one, the one that I've underlined in orange, there's nothing out front, right? There's nothing to distribute, so I just leave that one the way it is. 7x squared plus 6x minus 2. Okay, now what about the next one? So now we're going to subtract 5x squared minus 8. So I have to distribute the negative sign. So what's that going to give me? Good, plus 8. And then finally, now we're going to add the purple one. And so I just distribute a 1. It doesn't change anything. So then I just add 3x minus 4. Now all I've got to do is just combine like terms. So what about the x squared? 7x squared minus 5x squared is? 2x. Okay, so those are taken care of. 6x plus 3x. There's my 9x. Negative 2 plus 8. 6 minus 4.
2.
Okay, and if we want to check, let's just verify that this works. If I plug in 1 for x, let's see what we get from each of the parts up here. What about the orange part? If I plug in 1 for x, doesn't that just give me 7 plus 6 minus 2?
Yes.
So I get 11 minus what? If I plug in 1 for x, I get 5 minus 8, negative 3, right? And then plus, if I plug in 1 for x, I get 3 minus 4 is negative 1. What does all that add up to? 11 minus negative 3 is good. 14 plus negative 1 is 13. Okay, I should get the same thing if I plug in 1 down here, right? If I plug in 1 for x, well, that's just going to give me 2 plus 9 plus 2 equals 13, right? Okay, so we're good. We know that one's correct. Okay, next one. Have at it. I'll give you 2.5 minutes.
What is college algebra considered? Is this the same thing?
It's actually Math 95, but this is got everything you do in
What
one
did you
view.
So did we go into
We don't have that one.
College? Yeah.
This is the
Wait.
second one.
Well, our number two's different.
You don't have that one? Oh, never mind. Yeah, you're going to that one. That one. I'll start over.
Mr. Owen. College algebra. There's no chance we can be in that in college.
No, college algebra still, that's only 95.
Yeah, I know, but so if we pass that, there's no chance in college we'll be in Math 95.
Then you would go to the next thing, which would be probably
Yeah.
105.
Yeah.
Yeah.
Did you really pull
But you still, if you pass 95 here,
Somewhat.
it's just, if you pass, and you will, if you pass the S back, then it's off, then you don't have to worry about it, regardless of what happens.
So what math were you?
When I went to college, yeah. I think first class was Calc 253. But I did. Okay.
Oh, I can see.
We go into 3 when we're done.
What's that?
You go into
You can go to 3.
I already got 3 right.
All right, let's see how we're doing here. Okay, but I should, there should be no talking. You guys it has to be on your own. You got to earn these treats. Kira.
I got it right.
Caden. Braden. Nice. Kayla. Patrick. Man, you guys are, wow. You're gonna bankrupt me. Audrey. Gavin Sales. Sarah? Oh, bad throw. Whaley. Oh, Haley. Ryan. Cameron. Okay, one last check here. See if anybody snuck in under the radar. Yeah, sure. Just step out right outside. Caleb Tremper. All right, let's have a look at this next one. Okay, click them down, close for a second. Everyone's focused up here. Okay, so what about this here? So this one, just properties of exponents is all this is. Let's put this in perspective. All we're going to do is we're just going to multiply this stuff together. It wants it in the form a x to the m, y to the n. So a is just going to be a coefficient, just some number up front, times x to some power times y to some power, right? When we multiply stuff, we can multiply in any order we want to. We don't have to multiply in a prescribed order. Does it make any difference with the order in which we multiply this stuff out? So let's be smart about this. Let's multiply the numbers first. So I'm going to have 10 over 1 times negative 1/5 times, then we'll do the x's. So I get x cubed times x. What's the power of x if it's just an x? 1, good. And then times y squared times y to the 4th. So what's all that stuff simplified to then? When I multiply fractions, the hardest part is probably multiplying the fractions. So I multiply fractions, wow, what's my rule? I multiply it straight across. So 10 times negative 1 is negative 10 over 5. What's negative 10 over 5? Negative 2. Okay, what about the x's? If I x cubed times x is x to what power? To the 4th. Like I said, if I multiply like bases, I add exponents, right? So negative 2 x to the 4th, y to the 6th, right? Okay, good. Now that one. Move on, next one. 2.5 minutes, go.
When you that one, do you just want to finish the attempt? What? You just want us to finish the attempt?
Yeah, that's fine, yeah.
Mr. I knew that before I even do it.
Hmm?
Looked at it.
Good. Gavin Sales.
Already?
Brett Reinhardt. Lauren Olson. Nice snag. Kara.
No.
Tyler Craig. Did I give you a second? Oh, I didn't. There you go. Cameron. Oh, that was a bad throw. Brett, Cameron. Sarah. Josh Whaley.
Oh, I told you it was.
What's that? All right, Jolly Rancher. You got a minute left.
I'm not a big chocolate man.
I got it right.
I told you, but I got it wrong. It was precious and wrong too. I don't know the answer.
Yeah, I didn't answer anything.
Wanted to answer. I don't want it. Hey, get out of here, boy. Get out of here, boy. I told you. Hey, my God, I didn't even get one.
Hey,
Hey,
that's
oh
fine.
yeah,
Here, Blake, I'll trade you.
oh yeah. Oh yeah, can I get one?
You didn't get one?
No, got snatched.
Oh, man.
Yeah, yeah.
Either watermelon.
Did you get your last one, Kim?
Yeah.
Okay.
Oh, no, I didn't get the last game.
You didn't get the last one?
You get 2 grapes.
No. Okay, think we're done here.
We done for the day?
No.
How did I do this right?
All right. Let's. Did I miss anybody? I think I got him. Okay, let's have a look here. So what about this one? Last one. Close those up for a sec, please. Close them up.
Everyone got that.
We're gonna play this game. You gotta play it right. Here we go. So what about this guy? If we're going to find the equivalent expressions, well, first of all, this would be an easy one for us to plug in values. Let's just show that that works. So if we want to pick, like I could say just arbitrarily, let's say we're going to let A equal 1, we're going to let, not B, we're going to let X equal 1, and let's let P equal 2, okay? And figure out what's the value of that expression going to be then. So if I plug that stuff in, I'm going to get 1 times 1 is 1 plus 9 is 10 minus 4 times 1 is 1 minus 2 is 2? 10 minus 2, everybody agree? Everybody with me? So I get 8.
Oh,
8's going to be the value of that first expression. Now we just got to find which one of those has a value of 8. What if more than one, I tried this trick and more than one of them gave me an answer of 8? I just pick new numbers and try again with those two, right? So what about this first one then? I get 4 times 1 minus 1 is 0, plus 9 times 2 is 18. That's not it, right? How about this guy? 2 minus 4 is negative 2 times 1 plus 9 plus 2. Let's see, did I do that right? Oh, no, that's negative 3, sorry. 1 minus 4, right? So negative 3 times 1 is negative 3, plus 9 is 6, plus 2 is 8. Right? Check, that one works. How about this guy? Negative 4 times 1 is negative 4, plus 9 is 5, minus 2, that's not it. And then 4 times 1 is 4, plus 9 times 2 is 18, that's not it. So it's B. Right? Okay, if I wanted to do this mathematically, what would I do? Here's what I would do. I would just say if we're doing this mathematically, I would just expand this one out, right? Simplify it, and then simplify each one of these until I found the one that matches, that gives me the same terms. So if I distribute the negative here, aren't I just going to get AX plus 9 minus 4x minus a negative is plus p, right? Those are my 4 terms. Well, if I distribute the 4 here, I'm only going to get 3 terms. So that's not it. What about here? If I distribute the x, I'm going to get ax minus 4x plus 9 plus p. Aren't those the same terms? Yeah. ax plus 9 minus 4x plus p. So it's B. See what I'm saying? Okay. All right. Right. Okay, one thing I want to do today is, it's that guy back there. There we go. Okay, so let's do 2 things. And we're going to be a little pressed for time, but we can do this. So close everything up. Close all those Chromebooks up, please. So first of all, let's review long division. Okay. So if we because we did that on Friday, but it's been a while, so let's review that process. If I'm doing polynomial long division, where does the x plus 2 go, the denominator? It goes out front, good, so that goes out front, and the numerator goes in the brackets, good. So the numerator, remember, there's one thing that doesn't show up here, but we gotta be careful. If we're missing a term, we have to include that with a 0 coefficient, because we have to have a column for every power of x, right? Starting at x to the 4th, all the way down to the constant. So we get 2x to the 4th plus 3x cubed minus x squared minus x minus 8. Okay, first things first. How do we get our first part of the polynomial, the first term? Right, we're seeing how many times does the leading term outside divide into the leading term inside, right? So in other words, 2x to the 4th divided by x is what? Yeah, 2x cubed, because if I divide like bases, I subtract exponents, right? So I get 2x cubed is my first term, okay? So what happens when I get a number with regular long division or a term with polynomial long division? Multiply. Good, so we're going to distribute this through whatever's out front. 2x cubed times x is just 2x to the 4th. 2x cubed times 2, what's that? 4x cubed. So that's going to go in the x cubed column. And then remember, all I'm going to do here is just subtract that whole thing. So the 2x to the 4ths cancel. What's 3x cubed minus 4x cubed? Negative x cubed, and I'll just bring the rest of this stuff down, right? And I start over again. So now, how many times does x divide into negative x cubed? So negative x cubed divided by x is what? Negative x. Well, I'm just dividing the number. I have negative 1 divided by 1. What's the power going to be? Or squared, good. So my next term is minus x squared, and I'll just distribute again, right? So negative x squared times x is negative x cubed. That's good. Those have to be the same. Negative x squared times positive 2. Negative 2x squared. Good. And we're going to subtract that whole thing. So those go away. Now be careful with this. Negative x squared minus negative 2x squared. Negative.
The two negatives cancel.
Right. So negative x squared plus 2x squared is x squared. And I bring the rest of the stuff down, right? We go again. Okay, so now how many times does x divide into x squared? Another way of saying that maybe is quicker to think about is x times what is x squared? X. Right? So my next term's an x. If I distribute the x, x times x is x squared, x times 2 is 2x. So we'll subtract the whole thing. X squareds cancel. Negative x minus 2x. What's that? Negative x minus 2x.
Negative x. Negative x.
No.
Negative 3x.
Yeah, negative 3x, right?
Wait,
Negative
what?
x plus negative
Oh,
2x is
yeah.
negative 3x. And then finally, last step. So now we've got x times what is negative 3x?
Negative 3.
Negative 3, right? So negative 3x divided by x is negative 3. Distribute that through, and I'm going to get negative 3x minus 6. And so I'm going to subtract that whole thing, the negative 3x's cancel. What's negative 8 minus negative 6?
Negative 3.
Good. Negative 2, right? Because I'm adding 6 to negative 8. Okay, so then my final answer is going to be this polynomial, right, plus negative 2 remaining over my denominator, right? Everybody agree? So it should look like that. That's my answer then. Agreed? Okay, I'm going to show you a great trick. You're going to love this. This is called synthetic division. Now, it only works if you're dividing by a linear polynomial. So the biggest power of x in the denominator is x to the first. If we had an x squared or an x cubed or something like that down there, this wouldn't work. You'd have to use long division. But if you have a linear polynomial in the bottom like this, watch how easy this is. This is so quick and easy. So all you have to do with synthetic division is you're going to draw a bracket. That's what the synthetic bracket looks like. It's just like a big L, and there's going to be two rows, a row there and a row there. The first row consists of just the coefficients of each term in the polynomial, including zeros if we're missing a term. So we're going to have a 2, just the numbers, there's no variables involved. 2, positive 3, negative 1, negative 1, negative 8, and then we'll put a remainder box underneath the last column. And then the number that goes out front, now you got to pay attention to this. This is a little strange. The number that goes out in front is going to be the 0 of the denominator. So what's the value of x that makes the denominator 0? Negative 2, right? So if I set the bottom equal to 0, don't I get the result x equals negative 2? So that's what goes out front, the 0 of the denominator. And here's all I do. This takes about 10 seconds to do. It's so quick once you get the hang of it. Okay, first thing you do is you drop the first number straight down below the bracket. Okay, here's the rule. Whenever a number appears below the bracket, you always multiply by the number out front. So 2 times negative 2 is negative 4, which means we're going to push a negative 4 up into the bottom of the next column, and then we add. You subtract with regular long division, but with synthetic division you add. So 3 plus negative 4 is negative 1. Okay, a number appeared below the bracket, so what do we do? Multiply. Negative 1 times negative 2 is, so we add 2 in the next column. Negative 1 plus 2. Okay, number appeared, so what do I do? So 1 times negative 2 is negative 2. Negative 1 plus negative 2. Number appeared, so I multiply. Right? Negative 3 times negative 2 is 6. Negative 8 plus 6 is?
Negative 2.
Okay, now I want you to see if you can correlate the numbers here with my answer.
Yeah.
Can you? Yeah, look what we get. 2 is my first coefficient. My next coefficient is a negative 1. My next coefficient is a positive 1. Next coefficient is a negative 3, and my remainder is negative 2. How about that? So, okay, so here's how you get the exponents. So you know that these are the coefficients, but this is the remainder, which means that the spot next to that is always going to be the constant, right? So we can make a little, so this is the constant. This is going to be the coefficient of x. This is always going to be the coefficient of x squared. The next one over is the coefficient of x cubed. And if there were another one, it would be x to the 4th. See what I'm saying?
Caleb Tripper.
See it again?
Can I pen back?
Okay, so the answer, so there's the answer. See what I'm saying? So there's the constant, coefficient of x squared, coefficient of x cubed, remainder. Okay? All right. You got a quick assignment to do on that. It's only 4 problems. Okay, one thing before you go, listen please. Let's put the Chromebooks away. Here's my expectation. For the next 3 weeks, we're going to push pretty hard getting ready for SBAC. So I want you guys staying, not getting behind. If you're behind, get caught up. Okay? Yeah, go ahead.
in the morning.
Good job, Audrey. You weren't talking to me today.
Yeah, I was surprised I got hold of him right.
That's good.
For me, I was switching signs.
Oh, yeah?
It's a slow morning.
Well, just
I
get
need to
used
get my
to checking
sleep
them. I want you guys to get
schedule.
used to checking
All my
them.
answers are right, the signs are just off.
Yeah. But if you check them, you'll catch that.
Yeah.
Okay.
Whoa.
I told Robert that, and he thought I said Good for you. Nice, good girl. I like that. Awesome. Keep plugging away at it. I'm proud of you. That's good stuff.
There's still some stuff that I didn't entirely understand.
Okay. Well, we'll get you in for TA this week, and yeah, that's good. That's good. Good start. All right. Have a good afternoon.
Aw, Tyler didn't use my leg scratchers. Except I polished up my track teams.
Oh yeah.
Spikes, yeah. Polish them up.
Nice. All right. Have a good one. You need to check one out today?
Yeah.
Okay, let's do that. All right.
Where are the papers at?
Oh, right here. Here are these guys. Boy, I'd sure like to see you kick tail on this SBAC test. That would be, you've been working pretty hard here. I think you're going to. I really do. I think you're going to.